All right. Hello, everyone, and welcome to today's webinar. My name is Alex Alvarez, application engineer here at KETIV Technologies. So joining me today is Ted Ward. Ted, can you hear me okay?
I can indeed.
Awesome. All right. Yeah. So I'm getting a notification on my end that it's muted. So hopefully everyone else can here on the webinar can hear me okay. So for today's webinar, we actually have quite a lot of information to show. So again, if you guys have been kind of keeping up with what we're doing here, we are going to be talking about reverse engineering with some of the Autodesk technologies. Now, if you guys aren't too familiar with the Autodesk products or even KETIV for that matter, just a little bit about KETIV. We are an Autodesk reseller. Apart from that, we are also an engineering consulting firm, right? So that means if your business needs help with designing needs, that maybe you guys need help with design automation, taking your product from design to manufacturing, we have a team of engineers here that can help you with that. And so today we decided to partner with Autodesk to kind of collaborate on this webinar. And then show you guys a workflow between PowerShape and FeatureCAM. So with that, let's go ahead and jump right into it, and then just go into today's webinar. So here's a little bit about us. So that's obviously Ted Ward, Autodesk technical specialist. I myself, an application engineer here at KETIV. Anything in particular, Ted, that you would like to say? Just a quick sentence or two on what you do there at Autodesk.
Yes, thank you, Alex. Yeah, just I'm a technical specialist for Autodesk based out of Windsor, Ontario, Canada. And I deal with anything really manufacturing. So that could be machining, it could be design, and it could be inspection. So yeah.
Awesome. Yeah, and as for myself, again, I do focus primarily on the manufacturing tool sets that Autodesk has to offer. So anything that has to do with PowerMill, FeatureCAM, if customers need some sort of help with training, consulting, or mentoring around those tools, that's typically where I come in here at KETIV. Let's take a quick look at the agenda. Ted, if you want to kick us off here with some of the points that you'll be talking about.
Yes, definitely. We're starting off in PowerShape, where what we're going to be doing is looking at some scan data, so importing the scan data and then using some of PowerShape's functionality, to build the solid. We're going to look at some feature recognition for things like holes, and then how we go about editing them. And then finally, before I pass it to Alex, we're going to be looking at a comparison analysis between the original STL file and any solids and features that I go ahead and build.
Awesome. Yeah, and then from there, I'll go ahead and take that part, right? So it is going to be a parasolid part, and then take it into FeatureCAM, and then show you guys around the software, apply some toolpaths, some of the different strategies that FeatureCAM has to offer. We will talk about machine simulation as well. That's a really big deal when it comes to obviously to some of the machining strategies and to FeatureCAM's capabilities. Talk about the NC code, and then we'll leave 10-15 minutes for some Q&A. So again, you guys, this is going to be an interactive webinar. If you guys have any questions, if there's something that you missed, something that you guys still quite don't understand, feel free to leave it there in the Q&A box. So I think with that, I'll go ahead and stop sharing my screen, hand it over to Ted, and then we'll jump into the technical demonstration here.
Okay, let me know when you can see my screen.
Perfect. I can see it here on my end.
Good. Okay, so like I said, what we're going to be doing is taking some mesh data, some scan data that could typically be from some kind of handheld scanning device, or an articulating arm with the same sort of laser attachment. So what we're going to be doing is just pulling that straight into PowerShape. We'll take a look at the model straight away, but again, typically with scan data, there's a lot of imperfections. Let's say there could be some noise, there could be reflection, or any of the good stuff that happens when we're scanning that it's going to hinder us in the sort of design process. But what we're going to be doing, this is a very feature rich part, so we're going to be looking at some of the functionality and technology that Autodesk has to help us go ahead and build this. So let's get into that. We haven't got much time to get through both. So let's start it off. Now, there's my mesh. Let's just quickly look at some of the information. What have we got here? 250,000 triangles. Now, how do we go about that? Typically in the reverse engineering process, we might be doing plenty of sections and re-engineering curves and that quite lengthy process. But what we have in PowerShape here, if I just click this will open up my my mesh modeling, my mesh fixing toolbar. And one of the good tools that we have is what we call the mesh segmentation tool. And we can do this in like an interactive manner or an automatic manner. So let's just do that straight away. Let's click on segment. And what it's really going to be doing is analyzing that mesh and then trying to fit sort of key shapes, as you can see in the box here, planes, cylinders, cones, and then we go ahead and sort of trim that. So I'm going to be going through how to do this. So in this case, first of all, we're going to look at planes, and we're going to, we can either do this in like a solid fashion or a surface fashion. So we can create either. So let's just hit preview, and what that's doing, like I said, is trying to analyze that mesh and look at all of the flat regions, the cylinders and any other sort of shapes in between. And what this does, it allows us to sort of analyze the fit. Once we're happy, and I can see here that, let's just quickly look at some options as well. What I've got here is, if I find a plane, let's extend it out, because ultimately we're going to be trimming this all together. And then one important function here, if PowerShape deems that surface or solid to be within, on the Z or the Z plane, the XY plane, the YZ plane, it will actually lock to that. So anything within that 5-degree angle. Okay, so let's move ahead here. So this is giving me the fit, so I'm getting instant feedback, and all I do here is left click and right click. So that's created a plane underneath, and then it sort of designates that area as white, so I know exactly what and where I've actually fitted these planes. So moving around the part here. Now here's one here that's getting good coverage, and I can left click, right click to accept. There's one in this sort of flat region here that I like. I just make sure that it's got enough sort of information to give me what I need, and I left click and right click. In this particular face, it's only sort of grabbed regions of triangles in this area. So what I can do is just increase this sort of similarity angle. So really it's going to include more triangles within the calculation. Once again, I can look over it and say left click, right click. And then all I do is just really move around the part. I'll try not to rotate too much, but once again, there's the fit, left click, right click. Let's move around to this side. Once again, I'm getting good coverage. There's the fit that I like, left click, right click. Move around this way. Now again, this one is not really getting triangles or enough information from that area. So all I do is just increase that similarity angle and hit preview. Keep going until I get what I need. Preview. Here we go, that's better coverage. And again, left click, right click. Okay, so moving up to the end of the part here, there's a good surface. I like that one. We'll come back to this area of curvature in a second. Let's just view from above as well. I'm looking to do, or to really grab that top surface. And again, left click, right click. And then for this region, we're going to do something different here. I'm just going to quickly switch into the manual segmentation tool. Once again, I'm going to view from above. Specifically, I'm just going to add a flat plane, and then what we're going to look at doing is utilizing some of PowerShape's direct modeling capability to do a shrink wrap and then do a replace face afterwards. So let's just give this a number, click in this area. Let's go up to about 40. That's giving me good coverage, okay, and then I'm just going to preview manually in this case, preview a plane and accept. Once we come back out, I'm going to switch now to cylinders and then preview. Whoa, let's just zoom back in. Let's just put this down a bit as well so we don't grab too much. There we go. Down a bit and preview. Whoops, let's just come back out of there. Let's grab that and go back in. Okay, just quickly analyze that again. Make sure that it's surfaces, cylinders, preview. So let's just increase that similarity angle a bit more. That's given me what I need. And then again, left click and right click. Okay, so I think I've got the main build of the form done. Right, so while we can, let's take that mesh, just quickly put this on level 10, just to help me in my design going through. Let's just turn that off. Now, again, we've got some surfaces, but what we're looking to do is really generate a closed solid from that. So I'm going to view from above again. We'll hit Control 2, and then I'm going to go and add just a simple surface along, to represent the bottom of the part. Put that at 125 millimeters. And then we're going to quickly just drag that just so it incorporates, all of the surfaces there. Okay. All right. So let's just use the filtering tools on the home page here. Let's just say all surfaces. And we're just going to change the color, something more appealing. Now, typically, if this was surfaces, that would require a lot of trimming. But one function that we've got here, obviously I want to convert that into a solid. Now I could just say make a solid, or I could use this function called automatically trim surfaces. So hopefully if I've got everything in the right position, it's going to go ahead and automatically do that for me. Which it hasn't straight away. Let me just have a look here. What am I missing? Let's reverse that one for a start. Let's just try that again. There we go. That was a simple case of reversing the surface just to give me the right normal on the bottom of the part. So again, this slider bar will let me sort of keep more or take away, more, should we say, from the trimming. But what that's done is given me a solid. And then from there, what we can do is move on, and go through the process. So let's bring that triangle mesh back. Okay, and remember I said I was going to do something different in this sort of 3D area. So let's just grab that triangle mesh. We'll hit Control K to look at that on its own. And then we'll do something slightly different in this area. So if I click on the mesh, I go to the Manage tab. What we're going to do is sort of select some triangles in a completely different sort of manner, in this case by discontinuity. I'm just going to drop that down to about 10, click on the triangles, and again I'm looking for nice sort of coverage on this 3D form. And again, it doesn't really matter that there's gaps and holes. PowerShape's quite tolerant of what it needs to do and those kind of scenarios. So if I just upgrade that angle to about 12, that's good. There we can go straight to shrink wrap. Now, if we hit preview straight away, what it's going to be doing is really sort of drawing a surface down onto those, the regions of the triangles that I had selected. This will allow me to sort of influence the ISO lines, or in this case, the laterals and longitudinals. And then these ones here, what this is going to be doing is giving us more control points, more of the, the ISO lines or the internal curves. Once we're happy with that, we can preview and then click OK. So underneath there, we've got, again, we can see a nice sort of accurate surface there. If I go ahead and pick that surface, what we can see there, it's actually like a trimmed NURB surface. So I don't really want that. But what we can do is analyze what we call the trim region editing, or the boundaries or the intersection curves. If I wanted to, I could go ahead, and delete these sort of individually. But really, if I go ahead and select all of the P curves, so again, I can just say select all P curves, get rid of them. That's going to leave me like the original surface shape. Let's change the color on that one as well. Okay, let's bring back the model. We'll just blank the mesh. Now, again, this is my active solid. And I said I was going to do a replace face function. So I select the face, I go to manage, and then, now I can start exploring some of PowerShape's direct modeling capabilities. And again, there's replace face. Now I've got a choice of what I'm going to replace to. So we're going to pick the surface I created. So really, hopefully it's now going to replace the flat face that I did with the new 3D sort of contour. And again, that's, there's my solid there. Now, again, obviously I can't go ahead and, due to time constraints, I can't really do the whole part, but now what we're going to be doing is looking at how we can, let's do it the other way. Let's grab the mesh, hit Control K. Now we're going to look at some of these holes here. Now, really, these holes have been originally, in the original design intent was to go through the model, but if we were to rotate round, again, we've not really got much, we've got sort of very minimal data to work with. So what would we do and how would we go about it? So once again, I am going to pick the mesh. Really I'm going to direct it in myself here to sort of do it a bit more interactively. So I'm going to use manual segment. I know that I want to do cylinders and I want them to be solids. This would be surface, that would be solid. And once again, all I do is just zoom in and I'm looking at that hole and just trying to pick areas that give me the most sort of coverage or the best triangles. I'm trying to, I know this is sort of going to be a cylinder. I'm looking to try and space those regions out. But once again, I can click, check the fit, and then move on. So let's move as quickly as we can around these holes. Now, again, there's other ways of doing it, but this is just to highlight sort of some of the more, feature recognition bits of functionality here. And again, I didn't see that fit. It's over the top of the triangles. I think that's 05, but right click to accept. And then we'll do this region here. Hopefully everyone's not getting too seasick with all the rotations, but and we'll do this one over here. Now, we don't really know what kind of diameters were originally intended, but what we can do is then go ahead and sort of start editing and modifying them as a group. So I like that. Right mouse click. And again, once I come out of the form, what we should have is our solids. Now we have the original solid and we know we want to have these, going all the way through. Let's just turn the mesh off. Grab these particular solids. Okay, we'll hit Control K. And what we're going to do is quickly modify those colors as well. Let's give it something a bit brighter. Now, I could either modify them individually, but if we actually modify them as a group, first of all, I know the bottom of the part is at 0, so I'm going to globally move them, the bottom of the cylinders down to say -1 millimeters. We could then switch back to the dimensions, maybe make them all 40 millimeters high. And then if I switch the diameter, if I hover over this sort of red area, what it's going to give me is a range of all of the cylinders that they've been, the diameters that they've been created at. So 15.32, 15.38. So I think I'm happy to say that I could just pretty much make them all the same diameter, which in reality they probably would be. Then we can bring the model back. This is my active solid, and then it should just be a case of everything's intersecting correctly. And just go ahead and remove those from the model. Okay, so you can see we're quickly building up the features. What are we at? 118. Okay. Now let's bring that mesh back. Let's get rid of that solid for a minute. Okay, so we'll just look at these couple of sections in the middle and this hole going through. And I think we should probably be at time then. But in this case, we've got 2 cylinders, and a specific height that they need to be, joined at, for example. So once again, I go into manual segment. We are going to pick cylinders. They're going to be solids. And then once again, let's pick regions. So nice and wide apart to give me the most accurate cylinder. Right click. There's my fit, which looks good, and it's extended out by, I think it was 10 millimeters. So I'll accept that, and then we'll do the next one. So again, I'm looking for regions of triangles that are going to give me the best chance of fitting the most accurate model. Solid, should I say? Right click. I like that. And then once again, we come back out. Let's turn off the, actually, let's do this. Let's blank the first cylinder. Again, we really need to join them at this flat face. So what it's doing here is calculating or creating what we call primitives. So it should just be a case of, grabbing the top, stretching it. And I'm looking to see, just getting instant feedback that's going to help me through the process. Around about 30. Bring the other ones back. Let's blank these two. Change that color. Let's go this one. Oof. But like I said, what we've done, we grabbed this one and edited it and fixed it to that flat plane. So really, this one has to come down now to or be joined at that number. So what we're going to do is modify the top one. I'm going to right mouse click, say modify. Lock the X, lock the Y, because I like the location. But for the Z, I'm going to take a point off of this top cylinder, move it up, we'll apply. And then now, once I sort of take those two solid cylinders, we're going to append them, first of all. And now if I remove that from the main solid, we know we're going to be right on that particular face. So let's bring that back and do that. Bit of a bright color there. Okay, so let's take away the mesh. What about 121? Okay, so this now has to be my active solid. Everything is intersecting correctly, so we should be able to just grab that one and do a quick subtract. Once again, we should see, once we go and do a sort of a visual analysis, we hopefully should get, minimal deviation in these areas. And again, it was a rough triangle model, but these kind of tools allow me to, to really build accurate features from less than perfect data. Okay, so now let's just give Alex another hole to machine here. And this time we're going to be going through from the side here. And once again, probably scanning, it's captured some data at this end, minimal. Well, actually, this one was probably good, but what's going through on the side again is minimal stuff. So let's see what we can do there in this sort of scenario. And again, they're pointing, it's perpendicular to that front face, and PowerShape's going to hopefully allow me to lock it onto that because it's within that preset alignment angle. So let's go to manual segment. Once again, it's going to be a cylinder, solid, and we'll start over here somewhere. And again, I can adjust that similarity angle if I need to. So I'm just looking for good areas of data. That looks good. Better areas in this particular area. Let's add some more there. Let's go over to this one. That'd be good. And then finally, I think that's all we need, isn't it? So let's click and see what we get. Again, we've got a good fit because it's obviously going to be, the original design intent was a hole cutting right through the model. That looks good. Which I obviously didn't accept. I'll have to do that again. My apologies. Okay, that's good. Let's do that again. That was silly. I keep saying right click to accept, which I didn't do, but okay. And then over to this one. Okay. I like that. I like that. There we go. I think that's got it this time. Okay, there's the hole. Now we just need to make sure that that's going to be, all the way through. So I think all we need to do at this case, in this stage, is just grab that, change that color as well. Let's go for a blue color, and we'll bring that back. We'll get rid of the mesh, and then make sure that's the active solid. And then we should just be able to remove that one. Okay, and there's the hole going through. Now I would be doing a few more features, but I'm looking at the time here, so Alex has to get his bit in. So I think I'm going to finish up now with, I need to know how accurate that was. So now I go to visualization, and this is where we do an analysis on, the nominal triangle mesh. So we're going to pick that first of all. The target item, which would be my solid that I've put together. And then from there, we jump in and look at, how do we want to display this error? So I'm going to look for, positive 0.5 millimeter, negative 0.5 millimeter. Though again, that's, you can adjust that to whatever you want, but by hitting calculate, PowerShape should go away and really analyze, what's up, what's down, and we should get, red on anything sort of protruding from the model, and then blue areas showing, obviously like in this area that we haven't built something that's, within the model. So we should get green and then a nice graph of positive and negative error. But obviously this is only half the part. But again, some good tools to help you go ahead and quickly build up features like that. And I could obviously export this to a spreadsheet of some sort, take some nice sort of visual pictures for the customer or something. But again, just give me a final deviation and then good to go. So at that point, and to stop sharing and pass it back to Alex.
Awesome. Thank you for that, Ted. Yeah, and so again, the whole reason why we're showing this in the first place, right, is because this is actually a really, really common workflow, especially for companies that are doing a lot of R&D, or maybe there's companies that they're working with components or parts assemblies that are just outdated, right? That they don't have any information, they don't have any blueprints on the parts, and they're trying to reverse engineer, right? So again, the first step would be typically scan the item, bring it into a software that can handle this kind of data, and obviously give you the control to modify it. So even though it seems a little bit tedious, it's still something that gives you a lot of control to really modify the mesh, and really start working with it in the way that you expect the model to behave and then to actually turn out to. So now what we're going to show is we're actually going to go into FeatureCAM and then bring the part in that Ted was working on, and then go ahead and actually apply some toolpath to it, right? So let's go ahead and actually bring the part in. Again, if I take a look at what it got exported as, and again, I'm not sure, Ted, if you went into detail onto like what kind of file types you can export these models as. Is there
pretty much there's no limit, Alex. You can
no
pretty much, yeah, exactly. I mean, if you need a step, it can be step, but there's really no limitations to the export in PowerShape. But in your case, I gave you a ParaSolid.
Got it. Okay, perfect. Yeah, and so that's what we're going to be working with today, right? So we're going to be working with this mesh segmentation complete ParaSolid part. And so if this is your first time working with FeatureCAM, really the power behind it is that it's a feature recognition CAM software, right? So completely different from some of the other tools that are out there, in the sense that you don't need any sort of 2D geometry to drive that toolpath, right? So what I mean by 2D geometry, I'm talking about chains, or extrusions or islands. You don't need to really select any sort of feature in order to generate some sort of toolpath for the CAM software. And another thing with FeatureCAM is that there's a lot of automation built into the software. For instance, if you take a look at kind of what's taking place here in the first screen, it's bringing up a dialog box. Now you will see these throughout all of FeatureCAM. They're essentially going to be what we call wizards inside of here. And what they are is they're little steps, they're little tool tips is what I can consider them, that help the user, help the programmer move through the programming process a little bit smoother, right? Especially if this is their first CAM software, maybe this is the first time working with FeatureCAM. This is a perfect way to kind of see exactly what the software is expecting from the programmer. And again, you are going to see these little wizards come up, right? Especially when you're working with your initial setup. So we're going to go ahead and just define here kind of what our original orientation is going to be for our WCS. And you will see, like I said, a lot of this throughout the entire software, right? So little wizards, little steps, kind of just walking you through what it takes in order to program this part effectively. You do have the option to work with different type of stocks, right? So if you're working maybe with the cast, if you're working with the forge, you can work with that kind of starting point inside of FeatureCAM as well. And here we're going to go ahead and assume that we're starting off with just a block billet here, right? And then we're going to go ahead and say compute the stock from the actual size of the part, which again might not be ideal, but in my world, what I'm trying to see is just try to get a general idea of how much material I need in the first place. Now in here, what you can do is you can actually preview this. You can play around with the boundaries a little bit just to see if, okay, maybe I need a little bit more material on the top. What is the overall dimension going to be then if I do give that sort of allowance? Defining our WCS here, right? Making sure that everything here is in order. We get a preview of the stock. Everything here looks good. And then another wizard here kind of indicating, is this going to have any sort of multi-axis machining, right? You can say no. Is this going to be a fourth axis positional, right? If you have a rotary table or something of that nature, or is this going to be a fifth axis part? In our case, we're going to say that we do have a 5-axis machine at our disposal. So we're going to go ahead and say, yeah, let's go ahead and apply some of the 5-axis capabilities to this part. We're going to say finish that, right? And it shows us a preview here of our initial setup. Now, again, just kind of going through the user interface here, just to make sure everyone's on the same page. We have the tool ribbon here at the top, kind of walking you through the setups, walking you through the features. We have the browser here on the left-hand side, and then probably one of the most important ones is going to be the results tab here on the right-hand side. Now, this actually holds a lot of information. It doesn't quite yet, but once you start seeing some of the toolpaths and some of the features get programmed, this is where you're going to see a lot of helpful information kind of get displayed. Now, one of the things about FeatureCAM that I mentioned in the beginning of the session is the automation that's built into the software. Right. So again, Ted mentioned this when he was doing it, but this is a very feature-rich part. And even though we didn't quite get to all the features, it still has a decent amount of features kind of inside of here, right? And we also have a little bit of organic surfacing on the top here. So let's see how we handle something like this inside of FeatureCAM. The first thing that I always recommend customers to do when they're working with the software is make sure that you not only have obviously the correct NC file, right? The post. You typically, a post comes with the actual machine simulation file as well. If you guys take a look down here at the bottom of my screen, and then you also have to make sure you set up your tools correctly, right? So why is that important? Well, the way that FeatureCAM works is that it takes a look at your tool library, and it actually takes a look at the stock type that you're working with. Now, what I mean by that is it's taking a look at what kind of material you're working with, and it applies the correct toolpath strategies. It applies the correct feeds and speeds, all kind of in the background, right? So very, very limited interaction that needs to take place from the programmer in order to get some sort of toolpath out to the machine. Now, obviously, that in a perfect world, right, you would just click a button, have a fully part programmed. That's not really always going to be the case. So you do have the option to also do some sort of interactive machining as well. And we'll take a look at what that looks like here in just a bit. But just right off the bat, right, we're just trying to get some toolpaths out to the part, kind of see what the software does to begin with, and then we can go ahead and start modifying some of this if need be. So the first thing that we're going to do is that we're actually going to go ahead and apply automatic feature recognition. Right, and this is kind of where FeatureCAM makes its money here. I'm going to go ahead and select the actual command. It's going to tell me, okay, which solid do you want to apply feature recognition to? It automatically detected that solid, detected that setup, and right away it gives us a list of features here that it detected, right? And that's what I'm going to be calling these. So the software is smart enough to recognize features, right? Whether it's open contours, which is what it calls sides, holes, pockets, islands, right? So all of these are actually going to be features that the software can recognize. Now, inside of this list, you do have the option to deselect some of the features, right? So maybe there's a specific side that you don't want to machine just yet, right? Maybe there's a side here that you want to hold off for either for another setup or maybe for a different time. You do have the option to deselect some of these features that get automatically selected. But really, that's all it takes, right? So I'm just going to go ahead and finish this off, and then show me what it comes up with. Like I said, here on the left-hand side is the browser. So this is the actual feature that it programmed. It shows you a little bit more details here on the right-hand side, right? So based off of some of the machining attributes or some of the templates that I have created, it's automatically going to apply some of these toolpaths. Now, you will see that there's a few issues with some of the toolpaths here. Now, first and foremost, right, it didn't even apply a drill to some of these holes, and there's a specific reason why, right? If I select or if I hover over that specific error, it's telling me that it cannot find a twist drill for that specific size hole, right? And that's okay. That's going to be the case. I'm going to have tools in my library that don't necessarily correspond with some of the dimension features here. So what I can do is I can go back into the hole, go to the properties, and say, you know what? I actually intended that feature to be machined with a drill that I actually do have in my tool library, right? So I can go ahead and select the 11/32 drill there, select the second hole, select the drill, apply that, right? Hole number 3, select the drill. Now you're probably thinking, well, that's kind of a that's a really manual process, right? What's the reason for that? What if I have 20 holes, right? Do I need to do that 20 times? And you really don't, right? So the first thing that I want you to take a look at is that we just by selecting the actual property of the toolpath, we're able to now modify that toolpath and say, instead of using a drill that you couldn't find for a specific size, go ahead and just use the drill that we just selected, right? And it applies that and it takes care of the error messages for us. Now, again, that was a very manual process. What I can do is I can actually select a handful of features or a handful of toolpaths and apply a specific tool to those toolpaths. So take, for instance, we have a couple roughing passes here. You have a finishing pass, right, for the sides, it looks like. I'm going to be wasting a lot of time here transitioning between the 1/2 inch long and the 1/4 inch extra long. So why not just go ahead and just stick with this tool? I know I can machine these features with this 1/2 inch long. So what I'm going to do is I'm just going to go ahead and select all of these toolpaths and then override that with the 1/2 inch long end mill. Right? It's going to ask me, are you sure you want to go ahead and do that? In this case, I do. And it automatically overrided all of those tools, right? So again, instead of me having to do one by one, you do have the option to do it kind of all in one, right? In one single step here. And so really just like that, you just have code already, right? Which is the biggest thing when it comes to some of these parts, is you're just trying to get code out there. You're just trying to see either some sort of toolpath that's going to work for your parts, and then go in and modify, or you're just trying to, try to get something out the door relatively quickly. And so the last thing here that I want to take for this specific setup is going to be the surfacing feature here on the top. Right, so how do we handle that? If I take a look at some of the additional tools that we have here, so again, we just talked about the automatic feature recognition, and just like I mentioned, you do have the option to work with interactive features as well, and that's what we're going to use to program this surface here. So I'm going to go into the features tab. You have a couple options, right? For me, what I'm going to do is I'm actually going to go ahead and select surface milling. Right, so you do have surfacing strategies built into the software as well. And so we're going to go ahead and say, next, we want to go ahead and machine this surface here. Go ahead and select it. This is where it gets interesting, right? So again, you do have the option to have a roughing operation, right? Automatically have the software pick a roughing operation, apply a semi-finish, and then apply a finishing strategy, right? So this is, again, where the automation comes into play into the software. For us, we're going to go ahead and apply a single operation and say next, right? And I'll talk a little bit about why I'm doing that here in just a bit. But again, we're going to go ahead and stick with this parallel toolpath. I'm going to say next. So you have your options. So if you're coming from another CAM software, or even some of the other Autodesk softwares with a parallel toolpath, you do have the very similar options, right? Where you can define which axis it's going to be parallel to. You can make it automatic, right? So kind of let the software choose the best orientation for it. I'm going to say finish. And then there is our parallel toolpath, right? We only have one ball end mill here in the tool library, so it automatically knew what to select. If if you have the option, if you have multiple options, there are ways to kind of push the software, kind of nudge the software into a specific tool for a specific toolpath. And for this one thing that I did want to point, again, we're working with a 5-axis machine, and depending on how much or how critical the surface is, we can really spend a little bit of time making sure that we're getting the surface not only accurate, but you also want to get a really nice surface finish, right? Especially with the 5-axis machine, you can use just the full capabilities of the machine in order to get nice surface finishes. And the thing that I wanted to point out is that for this toolpath, being that we enable the 5-axis capabilities, you do have the option to make this one a full 5-axis toolpath, right? So again, if you want to use lead lean, you have options here to make it vertical, contact normal, right? So you have specific options. You can specify the angles for this toolpath, and then now instead of a 3-axis toolpath, you just converted it into a fully functioning 5-axis toolpath. So again, really easy to go through some of these things. It doesn't take, an axis. You don't need to create reference geometry, or you don't need to create reference surfaces for that matter. It's just a very efficient process when it comes to programming inside of FeatureCAM. So I'm going to go ahead and say OK. And really, all of these features, again, within a matter of minutes, right, without me just kind of going into details, you can have toolpath within a matter of minutes inside of FeatureCAM. Now, the next thing that I want to do is I want to go ahead and take a look at some of these other features that Ted kind of added on here, right? So we have this hole that's kind of at an angle, and then the other hole here that's behind the part. So let's go ahead and apply just some additional setups for these, right? So again, it's just as easy as just going to your setup. For the 0, what we're going to do is we're going to go ahead and say align to part geometry. Pick the Z direction. We're going to go ahead and make sure that it gets aligned to that surface there, right? And then again, it is going to try to, oops, I think I selected the wrong axis there. So again, making sure that we have the correct setup reference, right? Because otherwise what it's going to do is it's going to try to create it based off of a different UCS there. So what I'm going to do is go ahead and write reference setup 1 essentially. I'm going to go back to the setups, go back to 0, make sure that it is centered there, right? Align to part geometry. Let's try this again. There we go. Right, so it should reference that center point that we have. Right now, you can kind of see what's happening. Right, so the z-axis is pointing in the incorrect direction. We're going to say reverse the z-axis, and then it should automatically point in the correct orientation there. Right, so we're going to go and say OK. Just like that, we have our setup number 2 created, and now we can go ahead and start defining the machining strategy for that hole. Now, again, for this one, what I'm going to do is I'm actually going to go ahead and use another interactive feature. Right, and you'll see here why in just a bit, but I'm going to go ahead and actually use a pocket operation for this one. Right, so this is a critical feature. I want to go ahead and bore this hole out, and what I'm going to do is I'm actually going to use the feature recognition capabilities within the software. Right, so I still want to extract the information with the feature recognition that's built into the software. And so for this one, we're going to go ahead and say next. We're going to go ahead and select the side surface for it. And then just really by selecting the hole, right, it automatically picks up the depth and it picks up the correct diameter that we need to bore this out to. Right, so we'll say next. You have additional features here if you did want to modify that. So again, you can kind of deviate from some of the geometry that it finds, which is really nice. Now, what I wanted to show here is if you take a look at this, we have 2 roughing operations and then we have the finishing strategy that gets created. Now, why is that? Right, so I've been talking about the automation that's built into it, and I've been talking about the templates that also get created kind of behind the scenes inside of FeatureCAM. If we take a look at some of the what we call machining attributes, right? So if I bring this up, you have the option in here to create your own machining configuration. Now, what that means is that what you do is you get your most experienced programmer that's out on the shop floor, and you just run through this with them, right? You take a look at some of the settings here. You take some of the experience that he has, right? So that some of the experience that he has throughout the years working at the company, you start applying it to this dialog box, and now what you have is you have all of that knowledge transferred into FeatureCAM. Right, so for instance, if we take a look at the tool selection, we can now take a look at the roughing tools, and instead of using multiple roughing tools, maybe in this case, for most of our parts, we've been using single tools to do some of our roughing. I'm going to go and press OK there. And again, you have tools or options for everything, right? So how you're leading into your surfaces for specific operations, right? Even coolant, right? You can select different cooling configurations. So you do have, even though there's a lot of automation built into it, there's a lot of different options that you can really fine tune and make sure that you get the most out of the the most experienced programmer there. So I'm going to go ahead and say okay. You still see the 2 roughing passes here, but that's okay. I'm going to go ahead and just say okay to that. If I take a look at that operation now, or that feature, it should now just have 1 roughing operation and then 1 finishing strategy, right? So again, really nice. Again, the last one here that I'm going to program before actually showing the machine simulation is going to be that last setup, right? So once again, go home, create a quick setup here, align to part geometry, pick the Z selection, which is going to be this one here. And it's doing that same thing. So we'll go ahead and say align to part geometry. Pick orientation, making sure that it is correct, right? And again, it's pointing in the incorrect direction there. So point it there. Say okay to that. And then once again, apply that pocket operation, right? So we'll say pocket, extract the feature recognition, select the side, come in here, select the actual surface itself, and then finish that off, right? Maybe the last one here, and I kind of overlooked this one, but the last one that we want to go ahead and machine, if you take a look at the setups here, we have this setup that's machining. So if I take a look at it, it's going to be side 2, right? And if you take a look at it, so side 2, side 4, and it should be pretty obvious here, but you get some error messages. If you take a look at it, well, not really error messages, you get warnings. And really what the software is telling you is that, hey, the feature or the dimensions of the feature and the tool that you have, they're not going to coincide, right? So you can't really machine this feature with a round tool, right? And so again, really this feature, we're not going to machine it with, in this setup. What we would probably do is rotate the machine and then just mill that flat out, right? Which again, you can absolutely do, right? So I'm going to go ahead and go to setup. Once again, define the 0, make sure it's off the center, align to part geometry, right? And then we're going to go ahead and say pick our Z direction. It looks like it's in the correct orientation there. So we're going to say okay there. Once again, a feature, this is going to be a side. We're going to extract that with feature recognition. Right, and then just select our surfaces. So we want that surface to get machined, or that's going to be our boundary surface essentially. And then this is going to be our opposite boundary selection, right? Making sure that we have the arrows pointing in the correct direction, right? So we're going to be machining on this side of the surface for that one, and we're going to be machining to the right of this surface here. So everything looks good. It's going to ask us if it looks correct. It does. Say finish to that and say okay there, right? And so really, again, just a matter of minutes. And again, even though this is a CAM demo, it's still typically this fast, especially when you have your machining attributes and your machining configurations. It makes it just a really streamlined process when it comes to programming here inside of FeatureCAM. Now, when it comes to actually simulating, right, you do have a few options. So you have your traditional centerline simulation. You can do a 3D simulation, right? And then, of course, you can also do your machine simulation here at the bottom. So I'm going to start off with just a 3D simulation just so we can generate the toolpath, right? Hit play. It's going to take a while here to kind of process the entire toolpaths that I have out. And it looks like it's milling or it's boring out that hole there. And then it actually does do the surfacing, right? So even for the surfacing, I didn't really talk about this, but you do have machining configurations that can apply to some of these surfacing strategies. So if you are doing a lot of surfacing and you find yourself often changing parameters or often changing settings, that's something that FeatureCAM can do really well, right? Is they can specify your step overs. If you have specific configurations for that, you can automate that inside of the software. Now, again, we're not just happy with the 3D simulation, right? We actually want to include the machine simulation here as well. Now, before I do that, again, pretty big common topic here with FeatureCAM is all of the automation that's built into it. One of the things that I wanted to kind of talk about a little bit as well here is going to be some of the macros that are out of the box included with FeatureCAM. right? So if I take a look at some of these, just kind of going through them quickly, you can kind of see what I have kind of incorporated or kind of at my disposal right now, which is the setup sheet and the import vice macro, right? But out of the box, you really have all of these different macros already created for you guys, right? So if you want to kind of do the export to Eureka, automatic export to NC Sim, or simulation, FeatureCAM to Vericut, right? You have all of these macros that automatically take care of some of these commands for you for right out of the bat, right? So again, utilities, you do autosave, bulk edit, you can do nesting macros in here as well. So there's a lot of automation. You're not just limited to working with the out of the box macros. If you guys are familiar with creating macros, or you guys have a kind of a knack for it, you can definitely customize this as much as you want, right? So you're not limited to just working with what's out of the box here. Now, what I'm going to do is I'm actually going to use this import vice, right? So make this as realistic as possible when it comes to actually simulating this. The first thing I want to do is make sure that I'm on the correct setup, right? And before I do that, if I take a look at the stock, doesn't really give us too much wiggle room here, right? So again, we would have to either hold the part up here. What I'm going to do is I'm actually going to extend the stock slightly, just so that I can hold it with my vice when I bring it in. Right? So make the thickness just a little bit more, 2.5, something that I can actually grab onto. And now what I'm going to do is I'm actually going to go through the import vice macro, right? And this is what it looks like when you run that command. You do have the drop down. You have the option here to work with a few vices out of the box as well. I'm going to go ahead and select this Raptor vice. If you wanted to change the orientation, you could change the orientation. Maybe you wanted to, fix it on a specific location or in a specific location at a specific point. You do have that option here as well. What's really neat about this and what I like about it is that you can add the parallels to this assembly or to this part file as well, right? And even take it one step further and say, what size those parallels are going to be. So I'm going to go ahead and import this. The one thing that I will point out is that you are going to get a lot of dialog boxes show up. And really, that's just the software telling you, hey, this is going to be a read-only file, or the vice is going to be a read-only file, so you can't make any modifications to it, right? And I'm okay with that. Didn't plan on making modifications to it anyways, so we'll go ahead and accept those dialog boxes, and then just let it kind of do its thing here. Right, and just like that, we have the vice imported into our part, right? And again, being that it knows exactly where the bottom of the stock is at, it knows exactly where to position everything, right? What's nice about this is that I can then come in here into my add-ins, select setup sheet, right? And then have a setup sheet for the person that's actually machining this part, right? Or for the programmer, if you guys are running multiple shifts even. So really nice. You can create detailed setup sheets. I know I've created some custom setup sheet macros, so if that's something that you're interested in, just feel free to reach out. But the last step here that I'm going to show is go home to my home tab, go to the machine tab, and then just run the simulation. Again, making sure that you have the correct simulation file here, right? So I'm going to go ahead and press play. What I wanted to show, and hopefully this one I didn't make that setting, but you can control the rotation for this, right? And what I mean by that is that sometimes, and I did change it, but for this instance, right, for some of these features, and this is the case for a lot of CAM softwares, you'll see that the rotation is actually opposite to this, right? So it's actually machining away from you. I already did the change here, but inside of FeatureCAM, if you want to make a change, just for your guys' information, when you have a 5-axis setup, you do have the option here to change which position it's going to machine in. Right. So again, obviously, you want to have as much visibility as possible when you're machining this. So so you always want to machine it, when it's facing you, if possible. And so again, the NC code, you're going to see it here on the right-hand side. Right, you can kind of see your rotations here as well. So again, I'm running a little short on time, so I do want to save some time for Q&A. So let me go ahead and jump back into my presentation here. We'll go ahead and open it up to questions, see if there's any any questions out there. I'll take a look at the Q&A panel. If not, guys, again, thank you all for tuning in. Like I said, hopefully you guys were able to pick up a thing or two here from the today's workflow. If you guys have any additional questions, feel free to reach out to either Ted or myself. And
Alex, it looks like you have 2 questions in the Q&A.
Okay, let me.
The first one is PowerShape a part of the PDMC collection or a separate product?
Got it. Ted, do you want me to take that one, or did you want to?
I don't actually know. It's definitely a separate product, but whether it's part of the collection, I don't know.
I don't believe it is, right, Alex?
Yeah, it's not a part of the PDMC collection. And actually, if you wanted to kind of see what was a part of the PDMC, you could just let's look it up real quick. But yeah, it's what we consider the power products is its own unique set of tools, right? So yeah, those tools are not included in the PDMC collection, right? So you can kind of take a look at what's included with some of this, right? So you have Inventor, AutoCAD, Fusion 360 are one of some of the more common tools. PowerShape would be its own tool. PowerMill would be its own tool, and then FeatureCAM. You do have that FeatureCAM with Fusion 360 subscription as well. So yeah, no, unfortunately, it's not included with the PDMC.
And the other question was actually, is FeatureCAM an Autodesk product? So the answer to that one you just kind of addressed as well.
It is an Autodesk product, yeah. So what I would consider 3 different tiers to the CAM portfolio that Autodesk has, right? So you have Inventor CAM, Fusion 360, then you have FeatureCAM, and then after that you're going to have kind of the high-end tool PowerMill as well. So yeah, so 3 different CAM products that Autodesk is kind of has the umbrella over.
That was all the questions. Unless there's any other questions, feel free to type them into the Q&A, or as Alex said, you can reach out to Alex or myself directly.
Okay, awesome. Yeah, so if there's no other questions, again, thank you guys for tuning in. Ted, if you have any last words before jumping off?
No, thank you to everyone.
Awesome. Yeah, thank you for jumping on as well, Ted. Appreciate it.
No problem, anytime.
All right, guys. Have a good one. See you on the next one.
Yeah, bye-bye.